All right, this is quiz number 27. Okay, now the goal here is to find this output voltage given an input voltage VG. Okay, so the first thing to note about this circuit is that these op amps are both in negative feedback configuration. So the output here gets fed back to the negative terminal. And so this guy will act to try to, because of the negative feedback configuration, will try to make the voltages the same between those two terminals. So since this is at 0 volts, this guy will also be at 0 volts. And we also know that the current that flows here, let's call that I1, is equal to 0. Okay. Also, this op amp here is also a negative feedback configuration because the output here is fed back to the negative terminal. And so this op amp will also serve to make these two voltages the same. Since this is 0 volts, we know that this guy is at 0 volts. So we know that this is also at 0 volts, and that, let's call that I2 is equal to 0. All right, so now we can just go through this this circuit. We know that this is VG, this is 0 volts, so the current that flows through here is going to be VG minus 0 divided by 1K. So let's call this maybe I3. I3 in this direction is going to be equal to VG divided by 1K. Okay, well, since there's no current that flows here, this current, I4, has to equal I3. So let's call this I4. It has to equal I3, which is VG over 1K. Okay. Now, we know the current through that resistor, and so we know that there has to be a voltage drop. The voltage drop here is going to be, the current times the resistance. And so this is positive, negative, and since this is 0 volts, this guy has to be, a negative voltage. So the voltage here, let's call that maybe V1. It's going to be equal to negative I4 times 4K, which is going to be equal to minus VG over 1K times 4K. The K's cancel out, so this is going to be minus 4 VG. Okay, so I know that voltage, minus 4 VG is the voltage. Okay, so I know that voltage. Now, I can't sum the currents here because this guy may produce currents. So, but I do know the voltage. Okay, so the voltage is minus 4G, and I know the voltage here. So that means I know this current. So this current's going to be this voltage minus that voltage divided by the resistance. So let's call this maybe the current in this direction. Let's call it I5. It's going to be minus 4 VG divided by 2K. Okay, so this is going to be minus 2 VG over 1K. All right, so that's the current, and so I know this is I5, and since this current is 0, the current that flows this direction also has to be I5. Let's call that, so let's say this current here is I6 is equal to I5, right? Okay, so I know that that's what that current is, and I also know this voltage. So I know this voltage, and lo and behold, this voltage here is VO. So this voltage minus, so in other words, this voltage plus 10K times I6 has to equal that voltage. So we know then that that 0, so if I were to write that out, I have, so this current I6, I6 has to equal 0 minus V naught divided by 10K. And we know what I6 is. I6 is equal to I5, which is equal to, we already know what that is, minus 2VG over 1K. Okay, so that means that, so let's see, let's just write that out then. We're going to have, I don't know, minus V naught over 10K is going to be equal to minus 2 VG over 1K. So that implies that V naught is going to be, the minus signs go away. I'll multiply 10K on the other side, and the K's cancel out, and so I'll get 20 VG. So V naught has to equal 20 times VG. All right, so my answer down here, V naught is equal to 20 VG. Hopefully that's the answer. Okay, so there is quiz number 27.